Hello guys, welcome back. So here we have another question from GATE EC 2019 based on network theory. And in the circuit shown, if V of t is equal to 2 sine 1000 t volt, R equal to 1 kilo ohm and C equal to 1 microfarad, then the steady state I of t in milliamperes is. And if we take a look at the circuit, it is R in delta form and C is given in Y form. So if you remember the delta to Y transformation formula, you can straight away proceed with that. And in case if you forget, I have made another video where I have showed you a method to quickly derive, like under 3 minutes you can derive the formula from scratch, and I have also shared some tips to remember the formula. So the link to that video is attached in the description below. And with respect to this question, here since the R's and C's are equal, you can try to form it like a balanced Wheatstone bridge and you can get rid of one of the C and then it simplifies. But if your R's are different, then you have to do it by delta Y transformation. Okay, so let us approach it. Okay, I already have the circuit. Let me copy it. So here I have this. So it will be easier for me if I convert my R's into the Y form. So then I'll get something like this. And if you see this node is anyway hanging, so you can reject this entire part. So it is just my R dash and C in parallel and they are in series. So here to go from delta to Y, what you have to do is you have to take the product of the adjacent ones. So R into R, and then you have to add all the resistances. So it is R plus R plus R. And since here your R's are same, all the R prime will also be same. So here it is R square by 3R, which is equal to R by 3. So my equivalent circuit now is this V of t. And if I go to the Fourier domain, it is 2 sine 1000 t, right? I can take my sine 1000 t as reference. My omega is 1000 here, and I'll call it 2 angle 0. And now I have this C in parallel with this R. So this again my XC will be 1 by j omega C, which is 1 by j into 1000 into my C is given as 1 microfarad. So it is 10 power minus 6. So this is nothing but minus j 10 power 3, right? And my R is given as 1 kilo ohm. So it is 10 power 3. So this is R by 3 for me. So which is 10 power 3 by 3. And this is minus j 10 power 3. And my next is also same element only. So this one and R. So minus j 10 power 3, 10 power 3 by 3. So if I take my Z to be my parallel combination of these both, what will I get? Minus j 10 power 3 into 10 power 3 by 3 divided by minus j 10 power 3 plus 10 power 3 by 3. So if I try to simplify, I'll get minus j 10 power 6 by minus j 10 power 3 into 3 plus 10 power 3. So 10 power 3 I can again cancel. So then it becomes minus j 10 power 3 by 1 plus 1 minus 3j. Okay. So this is my Z, and my equivalent circuit now becomes 2 angle 0 degree divided by some 2z, right? And I need to find I. My I will be nothing but 2 angle 0 degree by 2z. So my I is 1 by z. So my z is this thing. So 1 by z is 1 minus 3j by minus j into 10 power 3. And I require this in milliamperes. So I can take this 10 power minus 3 outside. So in milliamperes, this is what I will get. So if I take the j top, it will be j plus 3. So it is 3 plus j. And my answers are in these form, right? It's in the form of sine and cosine. And our reference we have taken as sine 1000 t. This is nothing but real of j into e power j omega t. And j into j sine will be minus, so I have to include a minus sign. So whatever I get, I have to multiply with minus j e power j omega t and take the real part. So I got 3 plus j. So I need to multiply it with minus j e power j omega t. So and take the real part of this. So here what I'll get? Real of minus 3j plus 1, and this is nothing but cos omega t plus j sin omega t. So real of this. So real part what will remain? 1 into cos omega t. So I'll get cos omega 3 t and minus 3j into plus j. So which is nothing but plus 3 sin omega t. So my answer should be 3 sin omega t plus cos omega t. So where it is? So here 3 sin 1000 t plus cos 1000 t. So C is my right answer. So I also said you can approach this in Wheatstone bridge form. So we'll also discuss that. So if you see here, this part of the circuit, if you observe, this I can write it out as like this. So from here, there is R, there is another R, and this C is coming, and then there is C, and there is another C, right? And there is also another R here. So if you observe this part, this is like a balanced Wheatstone bridge because the ratios are equal. So there will be no current through this arm. So which means that you can just take this out without disturbing the circuit. And now if you see, this equivalent form is nothing but you have an R and two C's in parallel. Sorry, series. So then what happens to the C? It effectively becomes C by 2 and you have 2R. So this again, if you simplify, this becomes 2R in parallel with R becomes 2R by 3 in C parallel with C by 2. And this is connected to your voltage source, right? Which is having a value of 2. So it is 2R by 3 is nothing but 2 by 3 into 10 power 3. This is this thing. And for C by 2, what it is? 1 by j omega C by 2, which is nothing but minus 2 into 10 power 3. And we also have a j, 2j into 10 power 3. Let's say current is in milli. What do we have? We have 2 by 3 and minus 2j. And they are in parallel. So it is 2 by 3 into minus 2j by 2 by 3 minus 2j. So this is nothing but minus 4j by 2 by 3 into 3 becomes 2 minus 6j, right? This is nothing but minus 2j by 1 minus 3j. So what was our z if we have it previously? So it is minus j by 1 minus 3j. But total g itself was, effective g itself was 2 times g. So it is minus 2j by 1 minus 3j. So here also we are getting the same thing, right? So from here the equations and steps are going to be same. So this is how you can also arrive at the answer without the delta y transformation.